In this lesson, we'll review the angle addition postulate and solve problems by applying it. We'll start off by measuring angles. Remember, we name angles either according to the vertex, so this would be angle B, but we can also give it a three-letter name, A, B, C, where the middle letter is the vertex. This looks like a 90-degree angle. It looks like it's a right angle. We're going to use this protractor to verify what it looks like. This is the place on the protractor that's going to be lined up with the vertex. And I also look for a 0-degree mark on my protractor, either the right side or the left side, to line up with one of my rays. So I'm going to line up my protractor this way. Again, the crosshairs of the protractor goes on top of the vertex, and my bottom ray here is lined up with the 0-degree mark. So then when I go to read this, I'm reading the blue numbers because 0 degrees, 10, 20, 30, this is a 90-degree angle. It is a right angle. The measure of angle ABC is 90 degrees. The next example is an obtuse angle. It is larger than 90 degrees. I'm going to again line up my protractor so that this part gets positioned on top of the vertex. But now I notice that my 0-degree line on my protractor is not correctly positioned on my bottom ray. So I'm going to rotate and reposition my protractor. And now that I've done that, it looks to me like this obtuse angle is somewhere between 110 and 120, 120 being here. So let's call it 118 degrees. It looks like it's 2 degrees less than 120. So that will be 118 degrees. And then we go on and we look at an acute angle, GHI. Once again, lining up our protractor, then pivoting the protractor so that the 0-degree line on the protractor is correctly positioned with the angle. I can see that this angle is, and I'm using the blue numbers because we're looking at an acute angle. It is between 60 and 70 degrees, right in the middle. Let's call it a 65-degree measure. And this time, when I line up my protractor for this larger angle, PQR, I want to take and use this 0-degree mark and line it up with this ray. I could have done it the other way, but this is just how I'm looking at it right now. So once again, I'm repositioning the protractor. And when I read all the way across, I definitely want the 150-degree mark. Definitely looks like a 150-degree angle. Sometimes you have to look real closely at the protractor. Now that we've reviewed how to read a protractor to measure angles, let's look at the angle addition postulate. If point D is in the interior, so inside angle ABC, then the measure of ABD plus the measure of angle DBC is equal to the measure of angle ABC. We want to think about part plus part is equal to whole. That's a good way of thinking of the angle addition postulate. And the first 4 examples all have numerical values with diagrams. We'll read the information and we'll mark up our diagram and solve for the unknown. So here's our prompt. Find the measure of angle KLM. KLM. So this is the measure of the angle that we're looking for. And we are given some information. KLB, this little angle here, is 26 degrees. And the angle that's right adjacent to it, BLM, is 60 degrees. So when we go to find the measure of the larger angle, again, we're going to use part plus part equals whole, so 26 plus 60 is equal to 86 degrees. And then I look at my diagram and I make sure that that makes sense. Now the example right next to it, find the measure of angle WVU. So again, we're looking for the measure of the larger angle, and the measure of the two smaller parts have been given. ZVU is 62 degrees, and WVZ is 50. Once again, we're going to apply the angle addition postulate. Because these two angles are adjacent, they share that ray, so the measure of the larger outer angle is 112 degrees, which is 50 plus 62. Okay, in this diagram on the bottom left, we want to find the measure of angle IJA. So this time, we want the measure of one of the smaller angles. And the measure of angle AJK is 61 degrees. So this other acute angle is 61 degrees. And the measure of the large outer angle, IJK, is given as 153 degrees. This time, if we call this unknown x, we can write an equation and solve for x, right? And the equation is going to be 61, which is the first part, plus x is equal to the whole. And then to solve for x, we can subtract 61 from both sides of the equation, giving us 92 degrees. Once again, looking at our diagram, making sure that what we just ended up with makes sense in the context. 61 plus 92 does equal 153. Okay, on the bottom right, this problem is asking us to find the measure of angle WDC. So we are asked to find the measure of this piece, and what has been given is EDC. The whole outer angle is given as 145 degrees, and the other little piece is that this acute angle, EDW, measures 61 degrees. So once again, we can write an equation. Well, first let's label this as our unknown. We can call it x again. And now we can write our equation that part plus part is equal to whole. And then when I go to solve for x, I'm going to subtract 61 from both sides, giving me 84 degrees. Once again, double checking. If this were 84 degrees and that is 61, it makes sense that the whole is 145 degrees. Let's look at the last example for this lesson on angle addition postulate. Gives us some information about angle measures as not only numerical measures, but algebraic expressions. And I've gone ahead and I've labeled my diagram, HGF. This angle measures 16x plus 4. The measure of angle EGF is 110 degrees, and the measure of angle HGE is 3x plus 11. And we have to find x, and we're going to do that by applying the angle addition postulate. Now, here's my first part, and then I want to add to that my other part. And I'm going to set that equal to my whole of 16x plus 4. And I'm thinking about how I would solve an equation that looks like this, remembering there's my equal sign. I happen to have two like terms on the left side of my equation. So let's combine those like terms. And that'll be 121 plus 3x is equal to 16x plus 4. And now you see I have an x on the left and an x on the right. So let's subtract 3x from both sides of the equation, giving us 13x plus 4 on the right. Let's subtract this 4 to get x by itself. 117 is equal to 13x. And now let's divide both sides by 13, giving us x is equal to 9. It asked me to find x. I always look back at my prompt and make sure I've answered the question that was asked. And that's a little bit about the angle addition postulate.